So my name is Bongani, and I'm speaking to you from the ING headquarters in Amsterdam, Netherlands. If you're wondering, many of us are still working from home, but I requested for special permission here to be present here so I could avoid any possible technical difficulties. Today, I'll be presenting to you about a journey me and my colleagues went through with our complex Docker builds. My official title is a data engineer, but over what you consider what I've been doing over the past year has been more backend engineering focused. Work in wholesale banking advanced analytics, and in particular, I work with a product called the Data Analytics Platform. The Data Analytics Platform is a performance-driven big data exploration platform. So what we initially wanted was a platform for where our data scientists and BI developers could focus on their jobs and not have to worry about setting up Jupyter Lab or setting up Spark in order to do their job. What we wanted was a simple click solution where a user selects a certain set of tool sets and a container spins up with the data readily available. In particular, what I work on is within work on data science in the box within the DApp platform. Uh, Data science in a box, or DS box for short, is a handy tool set to explore and analyze data and create models. Um, DS box includes a Linux environment with JupyterLab, VS Code, Python, R, Spark, and all kinds of flow, including Airflow, TensorFlow, and MLflow. DSBox in itself is completely containerized, and it runs on our powerful Kubernetes cluster. What you see to your right is a high-level architecture. So we have this lightweight API Callisto, which interacts with the DApp platform. And Callisto is in charge of creating user images, and we create those user images through GitLab, and those images will be stored in our JFrog Artifactory. Callisto is also in charge of deploying these images to our Kubernetes cluster. So at the beginning of this year, we realized that we're about to hit a wall. We're getting many new user requests for DSBox, and our code base was not the most pleasant to work with. So just to give an overview, our Docker files were about 400 lines long of Dockerfile steps. And for us as developers, it was difficult to understand where, if we need a change and if issues were addressed, if issues came up, where to address them. Also, our images which were produced were quite large, so they were about 5.2 gigabytes in size. This made it actually even slow to deploy and extremely slow to build the images. To give you an overview, in the best time, and one image would take about 90 plus minutes. And in the worst case, our GitLab pipeline would actually time out at the 2-hour mark. So coming up at the beginning of the year, we decided we needed to rebuild. We needed to make things better, stronger, and faster. Now, on to making things better. We decided to revisit the Docker best practices. And I won't spend too much time on this. What I will do is highlight some of the best practices we continuously do in our development process. So when you make sure you're adopting best practices, make sure the first thing you want to do is reduce your image size for faster builds, faster deployments, and it actually saves space on your registry. The first thing to do is remove any unnecessary packages or build steps. So this will be like removing development tools or debug tools which you include in. So in that case, as things which are not needed by the end user. So for example, here, Wireshark is not needed by the end user, so remove it. Another tip, which we also found out, was that if you're using a Debian-based Docker image, so and you're installing packages, make sure you include this no installs recommend. The Debian package manager actually installs recommended packages automatically, even though you didn't instruct it to. So it'll best to include that. If you're using a Red Hat package manager, you do not need to worry about that. That's handled automatically. The next thing to do is make sure, take advantage of your Docker Manager cache. Uh, so, sorry, remove any package manager cache. Once when you do an install, make sure you clear your package manager cache because this will end up being will remain there through the life of your Docker image. So it's good enough to remove it there. Also notice how the pack for an execution install that we chain it together, and this is to avoid having multiple steps. What you do not with multiple Docker steps, what you want to avoid to do is doing the one below. This will have, if you do the below, you'll have multiple Docker steps, and your Docker build will actually take much longer to to conclude, and you might actually hit where you installing from an outdated package manager. The next thing, take advantage of your Docker cache, and in order to speed up your Docker build. So when you want to do this, you need to realize that order is important when it comes to your Docker builds. So if you make a change to a code line, or if you to a Docker step, all the following steps in your Docker build will need to be rebuilt, and that's going to cause a Docker cache bust. So in order to avoid that, if you can identify any frequent changing, so like in this case here, you're doing code changes in this target file, it's rather best to put it at least most of the bottom. So you need to order your most frequently changing content to avoid any cache bust. Now, one thing we also did was to ensure that we parallelize our builds. So for us, our images, we initially had two sets of images. We had a Python 3.6 image and a Python 3.7 image. And within our CI/CD, we only had one job, which was executing this whole build step. And this is why evidently it took about 90 minutes, and in the worst case, 2 hours to actually complete the job. And what would actually worst case is that if there was happened to be some issue in one of the build images, the entire job would fail. So it was only natural for us to make sure that each build was produced by its own job. So what we ended up doing was we modified our GitLab CI/CD to build multiple images at a single stage. So we have a before here, and this is how before it looked. And after we did the changes, now we're producing all the images here, and we even added a third image. So next, we needed to make get stronger. There was a use case for us to have flexibility in our tooling. Currently, or previously, our form was for our users was to have it all or have it all. Users had little choice in what actually went into the DS box. They got a DS box image with all the tool sets. What we thought would be nice is that if we give the user an ability to choose what tools they want in their DS box images. So, and also this would also be advantage for us because if a user chose less tools, it'll actually mean a quicker build, and it'll decrease our Docker registry space. Less space would be consumed in our Docker registry. So to give you a problem description here, this is what we went through when going through this. Think of user A. User A wants Jupyter with CUDA. Well, that means we'd have to take our base image, put Python, put Node, and put CUDA in it. Whereas user B wants Jupyter with Spark, well, then you will have to take the base image, put Python, put Node, put Java, put Scala, and put Spark. Whereas user C, they want VS Code with R. So then for that user, would have the base image, would need to include VS Code and R. So as you can see, there are too many combinations to cater for. And if we were to introduce a new framework, a new tool, a new language, it'll introduce more complexity. So what we needed was some form of a structured dependency solution, but for Docker builds. What we came across was Docker Make. Docker Make is an open source open source project. It's a command line tool to build and manage stacks of Docker images. So with Docker Make, you can mix and match different sets of build instructions as a dependency graph to create maintainable and extensible stacks of Docker images. So for example, here on the right, and once we adopted Docker Make, you'd create a YAML file, and you can see here we'd have the base image, and it'll be taken from this Fusion base image, and would call it dev base. And you'd have all these other images, and for Docker Make, you'll have this requires to indicate that it's based on top of this other image. And for example, here we have this final image called data science image, and it requires this Python image, airline data image, and plant data image. And when you run Docker Make, you can actually see that you get sort of this dependency graph. So here we have the data science image, and it knows that for this data science image, it requires those three above images, and those three above images require that one, dev base. And dev base is based from Fusion/base image. So once we adopted Docker Make, we actually ended up with the following dependency layouts. It's a much clearer dependency layout for us. So remember, I mentioned that our Docker, we had this one single Docker image, which was 400 plus lines long. Once we adopted Docker Make, we were able to actually modularize our Docker build steps and break them up into separate different Docker images and base them off and lay out using Docker Make to indicate which one would be based off which one. So this is what we kind of got at the end, a much clearer dependency layout, and it made it easier for us as developers to pinpoint where a change should go, or if we need to introduce something, it actually made it much more clear for us. Now the next step we needed to go, as Jeremy Clarkson would say, faster. So to go faster, we needed to improve our Docker build speeds. Not many might know, but the Docker builder, which it comes with Docker, is quite a legacy builder. It has an outdated design, and the code base of the builder made it difficult to introduce any new features. So every time there's a new Docker release, there weren't that many innovative features. The Docker builder was tightly modeled with the Docker instructions and had a linear build design. It had suboptimal performance, and it uploads the entire context. And by that, I mean that even if you made a single change, maybe to even like the final build step, this Docker builder would upload the entire file, the entire context, even though you changed one line. So we found out that there's a new Docker builder called BuildKit. It's produced by Moby, or some people also call it Moby BuildKit. It's the new BuildKit builder, and it has new Dockerfile features and many bug fixes. It introduced concurrency building. It has lazy context uploading. So so with the build kits is that if you change one file, then one build step, then that's the only build step which would get uploaded. It has extremely better caching than previously. It protects your secrets and SSH keys. It works with and without Docker, and it's daemonless. You have the ability, if you want to containerize build kits. So if you want to, you can have a Docker within a Docker. It's also compatible with your old Docker files, so not many changes. You don't have to do any changes. And you might not know, but it's actually been available since Docker 18.09. Now, what did I mean that the legacy builder is actually is linear? Well, if you take a look at the left, when you run Docker build on your Docker file, the legacy builder actually goes from this top-down fashion. So it'll just go top to bottom, and it'll run each step in this linear fashion. Versus BuildKit, when you run your Docker build, BuildKit actually first transverses from the bottom up. So it does a transversion and it creates a tree, and it tries to identify unneeded stages or stages which can be parallelized. So what you get with Docker build is that once it runs your Docker build, it transforms it to this. So it can actually identify that it can run this in parallel and run these set of stages in parallel next to each other. So if you want to use BuildKit, how do you enable it? Well, it's quite simple. You can simply pass in this environment variable called docker build, docker underscore BuildKit1 when you're running your build, or you can set in your Docker daemon this following configuration, and you'll have Docker up and running. Now, there's some new news. This actually was announced last week. If you're using Docker Desktop on your machine, uh, feel free to update to Docker 2.3.50 because they've actually enabled BuildKit by default. So I'll actually suggest updating your Docker Desktop as soon as finished with this presentation. Now, I'd like to also do a quick demo on BuildKit. So I have prepared this Docker file here. You'll see here I have these set of build stages here, these build steps, and I run a sleep command, and I have another set of build steps, and I run a sleep command, and I produce this final image based on those set of build stages. Let me exit quickly. All right, cool. Let me zoom in. Now, I'm actually going to clear my Docker system. So everything I'm running on a fresh Docker system, and I'm not taking advantage of the cache. First, what we'll do is we'll run with the legacy builder. And there we go. There's the first sleep right here. Right, and there's the second sleep going. Exciting stuff. All right, and this took about 20 seconds to complete this image. Now again, I'm going to clear my system, my Docker system, so I'm not taking advantage of the Docker cache. And now I'm going to run it using BuildKit. And as you can see, the first thing, you already see that Docker BuildKit has a new user interface. And we're already at the sleep commands, and you can see they're actually running in parallel over there. And this took about 14 seconds, so nearly half the time of the other build. So, but just by parallelizing, we just about half the time of the Docker build. Back to the slide deck. Great. So other features of Docker build. Docker build introduces context mounting. So with the previous Docker build, if you needed to actually introduce a file and work on it, you needed to copy that file over. So as here, you copy the file over, you untar it, and if you're doing your best practices, you need to make sure to release it. But then you're only releasing it on the final layer. And remember, you have all these other steps, so you introduce more steps and more layers. Now, BuildKit, on the other hand, has this new single command. You just need to turn on this experimental syntax. Now, what the experimental syntax doesn't mean that it's going to go away. They're just not fully sure of the syntax. So these features are there, but in the future, they might change the wording or the naming of the syntax. So what you do introduce a syntax, and now you run the single command called a run mount, and you'll actually mount your physical hard drive or your the physical machine, and you'd mount the files and you'd operate on those files within your Docker image. And so you don't have to copy anything over. You don't have to make sure that you clean your Docker build as well. Another thing here, so with the syntax mounting, so don't do what's on the left, especially if you work in a security environment, especially if you work in a bank. Do not copy over your SSH keys or secret keys. Please do not do this, because this will allow your keys to be available later on. What you can rather do is using BuildKit, you can rather mount using the mount syntax, and now you mount an SSH, and BuildKit will know that you're mounting an SSH key, and it'll make sure that that SSH key is only available within this run step, and it's not available anywhere else within your Docker image. And you just indicate that you're passing over SSH keys when you run your build, also using this keyword. So I would want to talk more about BuildKit, but there's a lot of features. My best advice is for you just to turn it on, see what it does for you. There are other very good features like the cache mounting, which has extremely improved. But for now, I just suggest turn it on and see what BuildKit does for you. Now, wrapping things up, we made things better, stronger, and faster. And where did we end up? Well, our development process has become much easier with doing our Docker builds, and we were able to make quicker releases and introduce more user features much quicker. Our time for builds images improved dramatically. So our builds went from 90 to 180 minutes down to 20 to 35 minutes. Our size of our images were also reduced drastically, and we have a better understanding of our code base. We also were able to introduce flexibility in order to add new tools in the future. So I'd like to thank everyone for listening on the talk. If you're interested in more depth and hearing about it, there's a QR code here, and feel free to scan it, and it will take you to a presentation about the data analytics platform. Below it is a QR code for BuildKit, and if you'd like to learn more about BuildKit, that will take you directly to BuildKit. And if you'd like to know about DockerMake, there's a QR code for DockerMake. Thank you everyone for tuning in, and I'll be taking questions.
Yeah, so thanks a lot, Bongani, for the very interesting talk. We were having a look at the chat, but we don't see any questions so far. So if you have any questions, just let them know. Yeah, maybe you want to give some last words to Bongani?
No, thank you again for your presentation. It's especially sharing the QR code so that it's easy for everyone to have access to it. And then just a small reminder that we do have a question. Sorry, we do have a question. What do you know about Docker, and then that you wish you knew when you started out?
So I'm not sure if we still have Bongani in the studio.
Already left.
I'm still here. What do I wish I knew about Docker before previously? It'll definitely about Docker caching. I think that's one of the things people should, when getting introduced to Docker, you should know about the Docker caching and how to take advantage of it, because it's one of the factors which decides how quickly your builds are. So if you can't take advantage of the Docker cache, and your builds might take much longer than ever expected. So I definitely say make sure you know about Docker caching.